Hello viewers, in today's class we are going to discuss an important problem from definite integrals involving the greatest integer function, right? And in this class we are going to solve this integral which is from 0 to 1, and the integrand is e raised to x times greatest integer of x square plus 1, right? So here our integrand is e raised to x times greatest integer of x square plus 1, and we'll solve this integral by the definition of greatest integer function, right? And this problem is going to be very useful for the beginners. So let us start. So let us call this integral as I, right? Now see, here the limits of integration vary from 0 to 1, right? Now see, whenever we come across with greatest integer function, we always search for integers, right? So let us first see the limits. So here the lower limit is 0 and the upper limit is 1. So we can write x belonging to the interval 0 to 1, right? Now see, here we have the greatest integer of x square plus 1, right? So when x belongs to this interval, that is 0 to 1, let us see the interval in which this quantity, that is x square plus 1, varies, right? Now see, when x is equal to 0, then the value of x square plus 1 is equal to 0 square plus 1, that is equal to 0 plus 1, that is 1, right? And when x is equal to 1, then the value of x square plus 1 is given by 1 square plus 1. So this is 1 plus 1, that is equal to 2, right? So when x goes from 0 to 1, then the quantity which is inside the greatest integer function symbol, that is x square plus 1, it varies from 1 to 2, right? So this is the first step. So here x square plus 1 belongs to the interval 1 comma 2, right? So let us represent these two numbers on the real number line, right? So here we have 0, here we have 1, and here we have 2, right? And we see that between 1 and 2 there is no integer, right? So here this problem is a very elementary problem, but we can come across with problems where we may have integers between these two numbers, right? So we have already discussed these type of problems in our earlier videos. So here between 1 and 2 we do not have any integer, right? So what will happen? See, x square plus 1, it belongs to 1 comma 2. So the greatest integer of x square plus 1 must be equal to 1 by the definition of greatest integer function. Now see, since x square plus 1, it belongs to the interval 1 comma 2, so x square plus 1 may have a value, say 1.5, right? Because here we have 1, here we have 2. So when x square plus 1 is having a value 1.5, then the greatest integer of x square plus 1 should be equal to 1, right? Because greatest integer of 1.5 is equal to 1. Similarly, we can take one more example. Suppose x square plus 1 is equal to 1.1, right? Then the greatest integer of x square plus 1 is equal to greatest integer of 1.1, which is equal to 1, right? So the purpose of taking these two examples is to suggest that whenever x square plus 1 it lies between 1 and 2, then the greatest integer of x square plus 1 is always equal to 1, right? So now we can write this integral I as 0 to 1, and we have e raised to x times 1, right? Because the value of greatest integer of x square plus 1 is equal to 1. So we have now a very simple integral 0 to 1 e raised to x dx, right? And the integral of e raised to x is e raised to x, and the limits are from 0 to 1. Now substituting the limits and taking the difference, we have e raised to 1. First taking x is equal to 1, then we have x is equal to 0, right? So this is e minus 1 because e raised to 0 is 1, right? So the value of this integral I is equal to e minus 1, right? So this is how, by the application of the concept of greatest integer function, we can solve these kind of integrals.